Limiting Reactants Lab, created by Eric Loza, Jenny Vu, and Sarah Saavedra.
The purpose of the lab is to determine the limiting reactant by using the mole ratio and find the relationship between the reactants with the product by analyzing the precipitate created from various volume ratios. The mole ratio, desired mole to given mole, will be used to find the limiting reactant. Stoichiometry is the study of quantitative relationships between reactants used and products formed in a chemical reaction. It is based on the law of conservation of mass, which states that matter cannot be created nor destroyed. Some materials that were used in the lab included the samples of potassium hydroxide and copper sulfate, the burette and a clamp, a spatula, a ruler, a beaker, test tubes, and the test tube rack.
Knowing the equation, we first filled the one burette with 0.2 molar potassium hydroxide and the other with 0.1 molar copper sulfate. Step 2 was to dispense 5 milliliters of copper sulfate into all 8 test tubes. Step 3 was to add potassium hydroxide to each test tube according to the volume chart. Next, we added water in each test tube to fill up a total of 13 milliliters of solution. After that, we mixed thoroughly with a spatula and let it sit for 15 minutes. Lastly, we recorded the precipitation levels. After waiting 15 minutes, it was observed that in tubes 1 through 4, the precipitate levels increased, but once it reached tube 5, it started to level off and decrease into tube 8. Additionally, the color of the precipitate in the tubes were different. For example, in tubes 1 through 4, it was a light blue color, and in tubes 5 through 8, it was a dark green blue color. Data. When mixing both liquids, potassium hydroxide and copper sulfate, we saw that in tubes 1 through 4, where potassium hydroxide was the limiting reactant, the precipitate levels gradually increased. In tube 5, where there are no limiting reactants, the precipitate levels reached a peak. In tube 6 through 8, where copper sulfate was the limiting reactant, the precipitate levels gradually decreased.
Discussion. The pattern of the height of the precipitate in tubes 1 through 4 increases and levels off at the beginning of 5 through 8. In tubes 1 through 4, there were less concentration of potassium hydroxide, 0.2 m, and more concentration of copper sulfate, 0.1 m. As a result, the level of precipitate was less and the limiting reactant was potassium hydroxide. However, in tubes 5 through 8, the precipitate began to level off and decrease because potassium hydroxide met and exceeded the level of concentration of copper sulfate. This caused the limiting reactant to be copper sulfate. Our first error was putting the solution into the beaker first rather than putting the solution into the tube. In doing so, this left some of the solution in the beaker affecting our outcome. Our second error was that we didn't mix the solutions correctly and it did not set properly after the 15 minutes. For the future, be sure to pour the solutions directly into the tube, mix thoroughly, measure more precisely, and make sure the liquids are adequate.